Cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
There's a force out there so powerful, it's actively pushing entire galaxies apart. It's a force we can't see, can't touch, and can't yet fully explain. Scientists have given it a name, dark energy. And here's the mind-bending part. It makes up nearly 70% of our entire universe. Yet, for all its power and prevalence, we know almost nothing about it. It's the single biggest mystery in all of cosmology, a silent ghost shaping the fate of everything. How did we even find out about something so elusive? The story begins in 1998. Two independent teams of astronomers were studying distant supernovas, the explosive deaths of massive stars. They were using these stellar explosions as cosmic mile markers to measure the expansion of the universe. The prevailing theory at the time, based on everything we knew about gravity, was that the universe's expansion should be slowing down. Gravity, after all, pulls things together. So, over billions of years, the mutual gravitational pull of all the galaxies should be acting like a brake on that initial Big Bang momentum. But what they found was the complete opposite. The data showed that not only was the universe still expanding, but it was expanding faster and faster. The expansion was accelerating. This discovery was so shocking it won the Nobel Prize. It meant there had to be some other force at play, something invisible and repulsive that was overpowering gravity on the largest scales. This mysterious something was dubbed dark energy. It was a placeholder name for a phenomenon that had just turned our understanding of the cosmos completely on its head. So, what have we learned about dark energy since then? Well, we know more about what it isn't than what it is. It is not matter, neither the ordinary kind that makes up stars, planets, and us, nor the dark matter that holds galaxies together. It's not any form of radiation we can detect. It doesn't emit light, it doesn't absorb light, and it doesn't reflect light. It's completely transparent. The only reason we know it exists is because of its profound gravitational effect on the fabric of space-time itself. It's revealed only by the way it's accelerating the expansion of the universe on a cosmic scale, a force acting everywhere at once. Let's try to visualize how it works. Think of the universe as a giant, expanding balloon. Gravity is like the tension in the rubber, trying to pull everything back together. Now imagine someone is blowing more air into that balloon, making it inflate faster and faster. Dark energy is that breath. It acts like a repulsive force, an anti-gravity, while gravity is a force of attraction, pulling galaxies and clusters of galaxies together to form the cosmic web we observe. Dark energy is a universal push, driving those same structures farther and farther apart from each other over vast distances. It's an invisible pressure embedded in space itself, relentlessly inflating the cosmos. Where could this bizarre energy be coming from? One of the leading theories, and perhaps the strangest, is that dark energy is an intrinsic property of empty space. This is sometimes called vacuum energy, or the cosmological constant. According to quantum physics, a vacuum isn't truly empty. It's a bubbling, seething foam of virtual particles constantly popping in and out of existence. This quantum activity could give every cubic meter of space its own tiny but non-zero amount of energy. On a small scale, this energy is negligible. But when you add it up across the billions of light years of seemingly empty space in the universe, it becomes a dominant cosmic force, capable of pushing everything apart. If dark energy continues to dominate, what does that mean for the future of our universe? The outlook is chilling. If the density of dark energy remains constant, the universe will continue to expand at an ever-increasing rate. Galaxies beyond our local group will be pushed away from us so fast that their light will eventually no longer be able to reach us. They will disappear beyond our cosmic horizon, one by one. Over trillions of years, the stars within the remaining galaxies will burn out. The universe will become progressively colder, darker, and emptier. This scenario is known as the Big Freeze, or the heat death of the universe. A slow, silent, and lonely end to everything. But there's another, even more terrifying possibility. What if dark energy isn't constant? What if its strength is actually increasing over time? Some theoretical models propose a form of phantom dark energy that grows stronger as the universe expands. In this scenario, the repulsive force would eventually become so powerful that it wouldn't just push galaxies apart. It would overcome the gravitational forces holding galaxies together, tearing them apart. Then it would overpower the forces holding solar systems together, separating planets from their stars. Ultimately, it would become strong enough to rip apart stars, planets, and even the very atoms that make up matter. This violent end is called the Big Rip. We have no idea if or when this could happen, but dark energy holds the key. Dark energy remains a cosmic ghost, silent, invisible, and seemingly unstoppable. It is the most profound puzzle in modern physics, challenging our fundamental understanding of space, time, and energy. We may not have the answers yet, but every new observation from telescopes like the James Webb and every new theoretical model brings us a small step closer to unmasking its true nature, and in doing so, we might just discover the ultimate destiny of our universe. Thank you so much for joining me on this journey into the unknown. If you're fascinated by the mysteries of the cosmos, be sure to hit that like button and subscribe for more deep dives into science. See you in the next one.